Hello friends, myself Mukesh Bhoge. In this video, we are going to see the concept of first shifting theorem. Firstly, we are going to see the statement of first shifting theorem. After that, its meaning, then working rule, and some example based on this first shifting theorem. Let us start from its statement. If the Laplace transformation of f of t equal to f of s, then the Laplace transformation of e raised to at into f of t equal to f of s minus a. So this part is your first shifting theorem. Okay, and the meaning of this equation is, if the function f of t is multiplied by exponential function e raised to at, and you have to take the Laplace transformation of e raised to into f of t. Okay, so firstly you have to take the Laplace transformation of f of t ignoring this e raised to at. So you will get f of s, because the Laplace transformation of f of t is f of s. After getting f of s, you have to replace each s by s minus a. So it becomes f of s minus a. So this is the meaning of first shifting theorem. In another word, the Laplace transformation of e raised to at into f of t equal to Laplace transformation of f of t, and replace each s by s minus a. The another form of first shifting theorem is Laplace transformation of e raised to minus at into f of t is equal to Laplace transformation of f of t, and replace each s by s minus a. Okay, so if your function f of t is multiplied by e raised to minus at, the power of exponential function is minus at, then you have to replace s by s plus a. And if the power of exponential function is plus at, you have to replace each s by s minus a. Okay, let us see the working rule for first shifting theorem. With the help of this working rule, you get some idea how to solve the problem based on this first shifting theorem. So step 1 is, consider given term as a function of t. So whatever your question, you have to consider that question as a function of t. In step 2, apply the Laplace transformation on the step 1. In step 3, take the Laplace transformation excluding e raised to at or e raised to minus at from step 2. Basically you are using here first shifting theorem. So meaning of this step 3 is, you have to take the Laplace transformation removing the exponential function. Then you will get here f of s. Okay. Step 4, replace each s, whatever f of s get in step 3, you have to replace each s by s minus a or s plus a. So this is the working rule for first shifting theorem. Let us see the idea of this replacement. Okay, suppose you have to replace this bracket s by s plus 2. Okay, and this bracket contain s. So after replacing s by s plus 2, obviously we are getting s plus 2. Okay, second example, you have to replace this bracket by s minus 1. You have to replace each s by s minus 1. So after replacing each s by s minus 1, basically you are replace only s, not s square. Okay, so just remove this s, and after removing this s, fix this s minus 1 to this s, so you will get s minus 1 bracket square. Okay, so in third example, you have to replace each s by s plus 3, and if I am replacing this numerator s by s plus 3, obviously I get here s plus 3, and this s by s plus 3, so we get s plus 3 bracket square plus 4. So this is the idea of replacement. Let us understand the concept of first shifting theorem or first shifting property by solving the example. So our first example is, find the Laplace transformation of e raised to 2t into sine 3t. Solution. Let f of t equal to e raised to 2t into sin ct. So here we are just considering given term as a f of t. Then applying Laplace transformation on this f of t. Okay. So we get Laplace transformation of f of t into Laplace transformation of e raised to 2t into sin ct. Then by first shifting theorem, because sin ct is multiplied by exponential function, so we have to use here first shifting theorem. So we know that the statement of first shifting theorem is Laplace transformation of e raised to at into f of t equal to Laplace transformation of f of t and replace each s by s minus a. We have to ignore this e raised to at part, just take the Laplace transformation of this f of t. If we compare this e raised to at into f of t to our example e raised to 2t into sin ct, you will observe that a equal to 2 here. So by using this formula, we get Laplace transformation of sin ct. We are ignoring this e raised to 2t part and just taking the Laplace transformation of this sin ct. Okay, so Laplace transformation of sin ct and replace each s by s minus 2. In next step, we have to take the Laplace transformation of this sin ct by using the formula Laplace transformation of sin of at is equal to a upon s square plus a square. So a is equal to 3. Okay, so our next step is 3 upon s square plus 9, because 3 square is 9. Okay, and replace each s by s minus 2. So this step is as it is. Okay, in next step we have to replace each s by s minus 2. So we get 3 upon s minus 2 bracket square. We are replacing this s. Okay, we are replacing here this s. So we get s minus 2 bracket square plus 9, and this is the Laplace transformation of e raised to 2t into sin ct. Thank you.